Namaste. I am I am Rohan Majankar, and in this video we will deal with input output model, and we will derive the input output model with only two industries for an economy. First of all, let us begin with the meaning of input output model. Input output model is the quantitative economic model that represents interdependencies between different sectors of a national economy or different regional economies. This means that it shows the interlinkages between the various sectors within the economy, such as in the context of Nepalese economy we can derive in the context of Nepalese economy we can divide the entire Nepalese economy into 15 sectors, and if we deploy the input output model in the Nepalese economy, then we can easily derive the interlinkages between those 15 sectors, and we can also derive the multiplier effect, also known as the chain effect, on the supply behavior of the industries. This means that the input output model shows the intra and interlinkages and their uh, and their inter demand and supply within the economy. So the input output model shows the interdependence of the various sectors, and it also helps to determine the multiplier effect, also known as the type 1 multipliers, type 2 multipliers, and type 3 multipliers. But in this video tutorial we will not go far beyond these multipliers, as this video is designed only to capture the basic information of the input output model, and we will learn to derive the input output model through the input output table and the transition tables. So now, dealing with the static input output model, there are two types of static input model. One is open model and other is closed. One model is open of transition for or within sectors besides the intra and inter industries transitions. Means that in the open model, the input output model also incorporates the household sectors, government sectors, and external sectors. But in closed model, we will only deal with the intra and inter industry transitions. So now, what are the features of input output table? The first feature is symmetric, means that supply must be equal to the uses, and the input output matrix must be a square matrix, means that the rows must be equal to column. And the input output table consists of intermediate consumption, means that the intra and inter industry transactions. As I have already told that the Nepalese economy can be divided into 15 sectors, and if we if we incorporate the intertransaction between these sectors, then it is called the intermediate consumption. And the final demand is the final demand by household, business, government, and external sectors. And in this video tutorial we will only incorporate the demand for household, demand by household. And the total output, it's output by each industry, it's the total sum of final demand plus intermediate consumption. Also includes value added, compensation to employees, and imports. But in this video tutorial we will not include this last portion because it makes our discussion complex. And column entries typically represents input to an industrial sector, while row entries represent output from a given sector. These last two lines are the most important lines to understand the input output table, and if we understand these two lines, if we remember these two lines, then our life will be easier when understanding the input output table. So now let's proceed towards the assumptions. Each industry produces single output, constant return to scale, and the input output portion is fixed. It means that the production function is of Leontief type. Leontief type means that if we use the capital and labor in a certain portion, then we cannot change its portion. Such as we can take the example of plow. In a plow, there is two ox and one man, and this ratio is constant. And this is the typical or the best example for the Leontief type reduction function. Based on these assumptions, we can define Xij as output of ith industry used as an input by jth industry. This means that ith industry will produce only one output and jth industry will produce only one output, and these two industries will have the simultaneous demand and supply of their goods, and they will demand for each other's goods. Means that the output by ith industry is used as an input by jth industry, and vice versa. Means that the output of jth industry can also be used as the input of ith industry. So now this is the basic input output table. The industries, industry 1 and industry 2, and when go and when moving towards the row, when when, when moving along the row, we will this row, if I move along this row, then this is the supply part. This is the supply by industry 2, and when moving along this row for industry 2, this is supply by industry 2. And let's wonder why it's supply. So for this we shall move on to these descriptions. X11 equals to output of 1 used as input by industry I, or X12 equals to output of industry I used as input by industry 2. This means that X12, this part X12 means that it is actually the output produced by industry I but used as the input by industry 2. This means that the industry I has sold its output to industry 2. This means that it is supplied by industry I to industry 2, or industry double I, or industry 1 has sold its output to industry 2, and the final demand, it is actually the demand by the household sector or government sector or any external sectors, and this is also the supply by industry I. So this row column, this row shows so this row shows the supply of industry 1, and this column is actually the demand by the industry 1. Why it's demand and why it's cost? It's actually the uses, or it's actually the cost, because X21 is output of industry 2 used an input by industry 1. This means that industry 1 has purchased the output or product from industry 2. So it's actually the cost or the usage by the industry 1. In this tutorial, we will not deal with the primary labor input, and we will cover it in our next tutorial. So now we will deduce the relationship as x1 equals to x11 plus x12 plus x13 dot dot x1n plus d1. This means that x1 is the total output by industry 1, and the total output equals to total supply. It's the total supply. Let's move towards the previous slide number 5. It's actually, I have added x11, x12 and d1 equals to x1. And similarly for x2, I have done the similar procedure, exact same process in slide number 2, slide number 6, sorry, slide number 6. And similarly for x2, and the general form is xi equals to x1i plus xi2 plus xi3 plus dot 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 plus xin plus di, where xi is the total output produced by industry, produced by ith industry, where I equals to 1 2 3 and so on. But in our context we have assumed that there are only two industries in economy. So now, following the reducing the relationship topic, x1 x2 are the total output, and x11 x12 are their intermediate, or their intermediate transitions between them. And this only shows the relationship between the industries, that is x11 and x12 shows the relationship between the industries, but from this relationship we cannot deduce their, we cannot quantify the relationship. So now we shall quantify the relationship such that output of ith industry is input of jth industry. Then what amount of output of ith industry is required to produce a unit output of jth industry? This is the fundamental question, and this question gives the, this question quantifies the relationship between the output of ith industry and the output of jth industry. So we will introduce input coefficient as, let aij, which is the input coefficient, be the amount of output of ith industry required to produce a unit of product of jth industry. This is called the input coefficient. Since aij is the amount of output of ith industry required to produce a unit of product of jth industry, it means that amount of ith industry needed to produce the one unit of jth industry. Then we can now quantify the relationship such that x11 equals to a11 x1 and x12 equals to a12 x2. a12 is the input coefficient. Generally, in a general form, xij equals to aij xj. Here aij is an input coefficient. So now we can transform the equation in our slide number 6 as x1 equals to a11 x1 plus a12 x2 plus d1, and similarly for the industry x2, and we will rearrange or arrange in such a way that we will throw the x1 a11 x1 plus a12 x2 towards right hand side, towards the left hand side, and we will keep d1 on the right hand side, and again we will rearrange. So now after rearranging we will put our equation in matrix form, and finally we will arrive to our basic input output relationship. This means that, sorry, we will arrive towards our basic input output relationship, means that x equals to I minus a to the power minus 1, its inverse of the matrix, times d. This will give the total amount of output that each industry must produce in order to satisfy its final demand. It means that we will find the value of x1 and x2. This is the fundamental issue in the input output model, and following this we shall go towards our example. So now here we can see the example. An economy produces coal and steel only. There are only two industries, coal industry and steel industry. 1 ton of steel requires 0.4 ton of steel and 0.7 ton of coal. It means that 1 ton of steel requires 0.4 ton of steel, means that it's we are dealing with the input. So if we deal with the input, then we shall always look on the row, look on the column of the input output matrix. This is the input used by steel. It means that 0.4 ton of steel is used as an input, 0.1 ton of steel, and 0.7 ton of coal is used as the input. Similarly, for coal, the coal industry uses 0.1 ton of steel, means that coal also uses steel. So now from here 0.1 ton is the input, and it also uses 0.6 ton of coal itself, so it's the input for the coal industry. And from while viewing from the row side, from the row, then it is actually the supply. It means that steel supplies 0.4 ton of steel to itself and 0.1 ton of steel to coal. This is the fundamental issue where most of the students get confused, and if you understand the basics of the rows and columns, then we can easily solve the input output table as it has been solved in example 1. This is solved as 0.4 times x1 plus 0.1 times x2 plus 50 equals to x1. It's the final demand plus final output equals to the total output. And similarly for 0.7 x1 plus 0.6 x2 plus 100 equals to x2, and we will solve it in a similar manner. So you can look towards this solution, and finally our answer is 200 and 100, means that equilibrium, sorry, means that here is, since the industry should produce 176.5 unit of output and the coal industry should produce 55.8 unit of output so as to meet the total demand of the economy. So thank you. If you have any query, then you can ask in the comment box below.